Okay, now let's do our second example of this section. Here we have a double integral of e to the y times cosine x dA, where r is the region, x is from 0 to pi over 2, y is from 0 to 1. For a second time, I'm going to do this two ways. So I'm going to set up double integral. I'll do x, I'll do y on the outside, x on the inside. On the left, so y on the outside is 0 to 1, x is from 0 to pi over 2, and then we've got e to the y cosine x dx dy. And here, let's integrate the 0 to pi over 2 on the outside, the 0 to 1 on the inside, e to the y times cosine x dy dx. Okay, so here on the left side, I'm integrating with respect to x. Keep the outside integral the same. The inside integral I will do. Integrating with respect to x gives me e to the y is just a constant, and then sine of x from 0 to pi over 2. The dy stays the same. Sine of 0 is 0. Sine of pi over 2 is 1. So this is basically 0 to 1 of e to the y dy. And then integrating that, I get integral of e to the y is just e to the y from 0 to 1. So that's equal to e to the 1 minus 1. Otherwise known as just like e minus 1. Okay, let's check if we get the same answer over here. So now keep the 0 to pi over 2 the same. Integrate with respect to y, and I get e to the y. Integral of e to the y is e to the y, and cosine x I'm treating like a constant. Okay, from 0 to 1, dx on the outside stays the same. So then cosine, no, not, I'm plugging in these numbers for y, not x. So then 0 to pi over 2 on the outside. So that means I'm getting e to the 1 cosine x minus e to the 0 cosine x, and then dx. Let's simplify that. 0 to pi over 2 of basically, let's factor out the e's. So e minus 1 times cosine x dx. Well, let's integrate now. So the integral of cosine is positive sine. So I get e minus 1 is just a constant times sine of x from 0 to pi over 2. Sine of x of 0 is 0. Sine of pi over 2 is 1. So it's equal to e minus 1. Got the same answer. Everything is hunky-dory and the way it should be.